Dear colleagues, partners and friends, ladies and gentlemen, and most important today, dear Ionica Smeets. A very warm welcome to all of you with us here tonight at the Marsilius Kolleg. Our rector, Bernhard Eitel, originally planned to be here with us tonight to welcome you to this special event. However, due to a last-minute commitment, he cannot be here. He asked us to take over for him and also to give you all his very best wishes. My name is Friederike Nüssel, and I'm a professor of theology, together with my colleague Michael Boutros from the medical faculty and the German Cancer Research Center. I'm serving as director of the Marsilius Kolleg, Heidelberg's Institute for Advanced Study. The institute has a very special character and mission. We are committed to bridging the gaps between the different academic fields of Heidelberg University, in particular between the sciences and the humanities. Our core concern is the intensive and research-driven dialogue between the representatives of the different academic fields and cultures. Since its inception, our annually rotating fellows from all areas of the university and surrounding non-university institutions have been at the center of all our activities. Our mission also includes increasing the understanding and respect between different academic approaches and the languages associated with them. Based on our mission, the Kolleg has also been increasingly concerned with the topic of science communication, to bridge not only the gaps between different disciplines, but also those that exist between academia and the public. As we all know, this gap has become an increasingly live issue, attracting a great deal of public attention. Scientific results are increasingly doubted in the public sphere. At the same time, scientists are increasingly expected to contribute to solving societal problems, to take on public responsibility, and explain their research results in everyday, understandable language. For scientists, how we communicate about our research matters now more than ever. How can we respond to the changing societal demands? How can we better explain our methods and their potentials and limitations? And how can we communicate results in a way that the broader public can appropriately understand and apply them? The Nature Marsilius Visiting Professorship is a highly visible and undertaking to approach such questions in a systematic and continuous manner. It is a joint initiative of Holzbring Berlin, the Klaus Tschira Stiftung, and Heidelberg University, and I'm extremely happy that representatives of both of our partners are with us tonight. We are glad to join forces with these highly recognized institutions within their various fields. Both of these partners have a long tradition in fostering dialogue between academia and the public, and it is a pleasure for us to cooperate with them in this wonderful initiative.
So we are very grateful for the enthusiasm of our partners and for the commitment to our joint project, the Nature Marsilius Visiting Professorship. The Visiting Professorship maintains one overall objectives. We want to illuminate the importance of high-quality science communication and initiate also new discussions regarding forms of exchange between the academic sphere and the general public. We also believe that teaching science communication skills to students, to scholars at all career levels, is crucial for this undertaking and will also have a long-term impact beyond the visiting period of the Nature Marsilius Visiting Professorship. To reach these goals, we are trying to always attract and look for outstanding scholars and public intellectuals who stand for excellent science communication and highest quality journalism. Ionica Smeets is a perfect example for this, and we're very proud that she accepted the offer to join us for the summer term. She has already been very active and involved in many discussions and workshops at the Marsilius Kolleg, and it has been truly inspiring for us to have you here, to have everybody involved, students, junior scientists, professors, giving us even more to look forward at tonight's lecture. And I think the turnout also speaks to the really importance of the topic and the interest in your work. From the perspective of the Marsilius Kolleg, the visiting professorship has a strong influence already on the colleague and the discussions. First, it includes at least 2 public events, the fireside chat at the beginning of the visiting period and the public lecture towards the end, what we will hear today. During the term, the visiting professors also become an integral part of the Marsilius community. They participate in the discussions with the Marsilius Fellows. They interact with the Young Marsilius Fellows, a new program that we just started this year, and meet colleagues from university and also from many non-university institutes in the region. From our experience, this exchange has proved to be really enriching for everybody involved, for the Marsilius Kolleg, and I hope also for the visiting professors. And we hope that you, Ionica, already feel home here and really liked your time at the Marsilius Kolleg and in Heidelberg, and maybe even come back at some point. And we also hope that you bring something back to Leiden and your work from the experiences that you had here. As mentioned before by Friederike Nüssel, the visiting professorship is shaped by a collaboration of 3 different institutions, by Holtzbrinck Berlin, the Klaus Tschira Foundation, and Heidelberg University. We're very happy that a really renowned expert in the field of scientific communication, Professor Carsten Könneker, the managing director of the Tschira Foundation since 2019, will now take over and introduce Ionica Smeets in more detail, her CV, and kind of her work. Mr. Carsten Könneker, the floor is yours.
Dear Professor Nüssel, dear Professor Boutros, dear Professor Smeets, dear friends and colleagues of the Marsilius Kolleg, dear Frau Zetsche from Holtzbrinck Berlin, dear ladies and gentlemen, in addition to research and education, the Klaus Tschira Foundation also explicitly supports the field of science communication. The Nature Marsilius visiting professorship is one of the visible examples of our support. Through the expertise of internationally leading professionals in the field of science communication and science journalism, we, together with our 2 partners, are able to sustainably boost this important topic for science and society as a whole. It is therefore a great honor for me to now introduce to you the holder of the visiting professorship of the current semester, Professor Dr. Ionica Smeets from the Netherlands. Please allow me to share with you some highlights of Professor Smeets' academic background. I'm coming to the journalistic background later on, because it's a lot. She studied applied mathematics at Delft University of Technology. In 2010, she received her PhD at Leiden University with a dissertation on continued fraction algorithms. From 2009 to 11, she worked as a postdoc in the field of public understanding of science. In 2015, she became professor of science communication at Leiden University, and there in the biology department. She and her group are now responsible for a master's program, Science Communication and Society, which attracts some 50 students from different backgrounds, like here in the Marsilius Kolleg, each year. Furthermore, Ionica Smeets is also an outstanding science journalist and author herself. Since 2004, she has been working as a freelance science journalist. In 2006, she started her first own blog, Wiskundemeisjes, Math Girls, together with Janine Dahms. Since 2010, she has her own column in the well-known newspaper The Volkskrant. In 2013, she created and hosted Ionica, a popular scientific show on Dutch national TV about mathematics. From 2015 to 19, she was an author and host of the National Science Quiz in the Netherlands. And until today, she wrote 6 popular scientific books. For her most recent books, Rekenen voor je leven, Calculating for Your Life, together with Edward van de Vendel, she received the very prestigious Dutch literary prize Zilveren Griffel. I hope my pronunciation is almost close to what it should sound like. Last not least, Professor Smeets also has a distinct research agenda in science communication. Her main research topics are bridging the gap between experts and the general public, and authenticity in informal learning. I'd like to close now, I'm almost done, by mentioning 4 examples of Professor Smeets' current research. 1, exaggeration in press releases on media coverage on health issues. 2, participants' experiences in citizen science projects. 3, differences in interpretation of jargon between laymen and experts. And finally, she's also developing evidence-based outreach material. Dear ladies and gentlemen, as you can see easily, Professor Smeets is an ideal appointment for the Nature Marsilius visiting professorship, as she combines academic research and practical perspectives on science communication, science journalism in one person. Hence, we are very much looking forward to her public lecture about lying with numbers. The stage is yours.
Thank you. Thank you so much for this lovely introduction. I must say, I would be pretty impressed with myself. But I was like, oh yeah, I did that too. But guten Abend alle. I will do the rest of the lecture in English. That will be better. But it is really a big honor for me to be here. It's also sort of a festival setting with all the people standing. I will also be standing for the entire lecture. Lying with numbers is one of my favorite topics to talk about because it touches upon both the things that I'm interested in academically. It's about numbers, and I'm a mathematician by heart, but it's also a lot about communication. So, because this is the public part, I thought I will focus most on the popularizing mathematics part, but I will add in some research about communication and how to do these things well. And I was talking to Ulrich. Where are you? Over there. I don't know how many of you were there, but 2 years ago, was it 2 years ago or more? 3 or more. So I found out when I was here in Heidelberg for the first time a few weeks ago that there was a seminar here at Heidelberg about lying with numbers. Were you there? Okay, so you were there. Well, so for those of you who weren't there, all their notes are online and you can check their reading material. So that is a sort of homework for all of you to read up on all of it. And today I will just do 4 topics because you could do many, but I picked the ones that I think are the most surprising or the most relevant or just the most fun. And I'll start with one that is one of my favorite paradoxes. It's called Simpson's paradox. And it isn't named after Homer Simpson, but after some dull statistician who was also called Simpson. But I always like to put this picture here because that's what your brain feels like the first time you encounter it. And just a quick check, how many of you are familiar with Simpson's paradox already? Okay, maybe I should check like how many of you were at the seminar now to see. So I will tell, there are many different ways in which this paradox was rediscovered, as often happens with mathematical ideas. And I will do a university example, since we're here at a university. So in the 70s, there was a question whether Berkeley, the American university, was discriminating female students who applied for a position at the university. And I have the numbers of 1973 here, and you can see, I'm not sure if all of you in the back can read it, but I will read it out loud. So it's almost 9,000 men who applied, and 44% of them were admitted. And a bit over 4,000 women applied, and of them only 35% were admitted. And this difference between 44% and 35% was significant, and it was something like that each year. So it wasn't a one-off. Every year the pattern was like this. More men were admitted than women. And there was a feminist group who considered starting lawsuits to figure out what was happening and to rectify this. Well, the first thing you want to do when you are considering this is figure out who is doing the admissions, where is this happening? And of course, the hypothesis was that there might be a room with older guys who were just throwing away these letters by female students, but that wasn't the case at all. First of all, there was no one room where people were selecting the letters. Each department was doing their own selection, so there were many different selection procedures. So if you take a closer look at the data, you can look per apartment, and I'm going to show the first ones. So let's look at the applications and who were admitted. So Department A had 800 applications of men, 62% were admitted, 108 applications of women, and 82% were admitted. So I always make the bigger percentage blue. So if A was discriminating, it was actually in favor of women. They had a bigger probability of getting in than the men who applied. Department B, similar pattern. So 560 men applied, 63% of them were admitted. 25 women applied, 68% of them were admitted. So also B had a slight favor towards women who applied. Well, you can do this for the entire university. I just do the first 6 ones. And in general, if you look at the pattern, you see that either the women had an advantage or there was a very small advantage for the men. And yet, if we go back to the entire university, then we see this. Then it's more men coming in. And now the question is, for those of you who have never seen this paradox before, why does that happen? So you can just shout a guess, I think. Maybe I should say I asked this once at a high school, and they figured it out in very little time. So, so what is happening here? Anyone wants to take a wild guess? Otherwise, yes, in the back. Yeah, so that is spot on. So what you see is that women apply mainly to departments that have a low admittance rate, and for men it's the other way around. So if you look at the most popular study for women, that was Department C. I think it was English literature or English, but they have an admittance rate of around 35%, while men mainly chose A, which was, I think, physics or something in the natural sciences, which had an admittance rate that was really high. So women pick the studies that have a lower admittance rate. And that's why you get this, that each department is being fair or actually giving women a bit higher probability, and then overall it flips. And that is Simpson's paradox. So you have a trend in different groups, and then it reverses when you combine them. I see some people already looking very Homer Simpson-like. Yes. And this happens quite a lot. So I will show some other examples. But first of all, a Dutch recent. There were some discussions in the Netherlands also about female applicants getting less grants than male applicants. And these were the numbers for some Dutch grant proposals. You know, here the numbers are so depressing, right? It's even the best ones only get 18%, but the females had 15% chance. And so there was a lot of discussion about this and a lot of articles like, are there things that are not fair in grant processes? And I must say, There might be. So also in Berkeley, we know that there are all these implicit biases that might bias things, but you need to also look at what is happening behind the numbers. And here was the exact same phenomenon. Also, women applied much more for grants in fields that had very low success rates. So these are the Dutch fields, and you see on the one axis the percentage of female applicants, and then you see the awarded proposals. And N stands for natuurkunde, natural physics in the Netherlands. And we see a very high success rate and a very low number of female participants. And you might say that there is something happening there, that the fields that are more male-driven get more money, or there could be a lot happening, but the grant proposals are not discriminating in this sense. You cannot say it from the numbers. And then you see where there's most female applications. So that's in the humanities, social sciences, health sciences. They have the lowest success rates. So also here, it actually flipped the other way around. Another famous example, so I thought today I will start with the academic one, but when I give a talk to medical students, I always start with this one. There has been a study how to treat kidney stones, and they had two different treatments. They had a small, cheap treatment and a bigger, more expensive treatment. And then they did a test to see which treatment worked better. And then they found that patients who came in with small kidney stones, that they had more benefits from the more expensive treatment. And they also found that patients who came in with large kidney stones had more benefit from the expensive procedure. Overall, on average, the cheap procedure works better. And also here, it wasn't a randomized experiment. So what happened is that most people who came in with small kidney stones got the cheap treatment, because that was the fastest, the easiest, and the cheapest. And quite often they had very little side effects because they came in with a small problem. While people who came in with bigger kidney stones immediately got the more expensive treatment, and they also had more problems and complications and side effects, not because of the treatment, because they came in with a bigger problem. And they did estimates after this study, and they expect an effect like this to show up in 1 out of 4 studies if you don't pay attention. To give some more examples without the numbers, but just to mention them, in baseball, a lot is based on numbers. And this is Derek Jeter, a hitter. And they have all these averages of the hitting averages. And you can have 2 players, and then the first player is better in 2 seasons in a row, but on average, the other player is better. And then which one would you buy? People go crazy if they have to decide. And one of the nicest ones, it wasn't an example from the theater here in Heidelberg, but I thought I would show this theater. I gave a talk about this, and then afterwards I got a letter from a theater director, or not, well, how do you say, manager of a theater. And he had seen this and he hadn't figured out what was happening. So he had changed, he had a theater with 2 halls, a small one and a bigger one. And he had changed some things in the way he programmed events. And he saw in both halls that there were more people coming, but on average there were less people coming to his theater. If you looked percentage-wise and how much of the lecture halls was taken. And then it turned out there was a change. So he started doing more in the hall that had a lower overall, how do you say it, show up. So that's why it was messed up. So he was improving both of them. But because the one that was doing worst was getting a bit more, it looked like he was going down. And this can also happen with teams, that you see teams who are improving, but then if the team that is a bit less than the other team is doing more work, then the average can go down, which is weird, but it happens. So that was Simpson paradox. And I think one of the nice things about it is actually that usually it solves itself, because when you encounter it, the doctors in the kidney stones experiment, they're looking at the numbers, they're like, this doesn't make sense. So this is one thing I think where human intuition usually intervenes before it gets wrong. Which was the good news for today, because the rest of the examples were where human intuition fails. This is, of course, a very classic example, especially with this heat wave. I don't know if you notice, but the more ice cream people eat, so that's on the one axis, the more people drown, that's on the other axis. Well, and this is a very, very clear thing you can see. So there are many statistics books that are warning that ice creams are dangerous and that we should forbid them. And of course, as I hope each and every one of you will realize, this is a very stupid way to think about it, because there's probably something else happening. It's not the ice cream that makes people drown. It's the fact that when the weather is warm, people eat more ice cream, but they also go swimming more often. Oh, you're like, yeah, maybe. Yeah. Yeah. So, and this happens a lot. So there's a correlation between two things. So you can make a nice chart like this with one thing going up and the other thing following. But it doesn't mean that there's a causal relation, that the one thing is causing the other. And one of my many weird hobbies is collecting these examples. And I'm going to show you some of my favorite ones. I like this one because it's an old picture of my son, who's now 11, but now he won't allow me to use pictures of him anymore. This was a study quite a while ago that got people very worried. There was a study that showed that children who sleep with the light on have a much higher probability of becoming short-sighted. And this article, as it goes, so this was a research article, but there was a lot of media attention saying, well, night lights are pretty much child abuse. Parents who did this should be worried. And lots of parents were really worried. But then they found a hidden variable that was behind it. Do you know, or are you guessing? Do you want to guess? What is it? Okay, so just scratching your head. So does anyone dare to take a guess what could be behind this? What, reading? That would be a good guess, yeah, but it's not the one. So I asked this to kids once, and the kid said, maybe kids who are short-sighted are more afraid of the dark. That would have been really cute. The answer turned out to be the parents. Short-sightedness is very much inheritable. And parents who are short-sighted are the parents who like night lamps, because then they bump into things less often. So it wasn't that bad with the night lights. This one is also a fun one. It turned out that people who wear a life jacket have a higher probability of drowning. And it is very similar actually to the ice cream, that when do you wear a life jacket on a boat? It's probably if the weather conditions are bad. So if you are sailing and it's nice and sunny and calm, you are not wearing your life jacket in general. My son is on a sailing camp right now. I do hope he's wearing his life jacket. But so it's the weather conditions here that are a much better predictor than the life jacket. And then one of my favorite new ones, because I really like chocolates. And I was checking how familiar this is in Germany. I asked some people, so did you ever hear that chocolate can cause migraines? Yeah, I see quite some people nodding. I also see people like, no. So as I grew up, this was something you heard a lot. So that chocolate causes headaches in general, but migraine specifically. And I know quite some people who have migraines who didn't dare to eat chocolate. And a few years ago, they found out that the mechanism is the other way around. So before you get a migraine attack, there are things happening in your body that make you crave sugar and fat and chocolate. But it isn't triggering the migraine attack. It's the other way around. And I know a guy in his 60s who's so excited because he hadn't dared to eat chocolate since he was in his 20s because he was so afraid of getting a migraine attack. So that is really nice. And yeah, you already mentioned it in your introduction. I also do research on how to communicate about these things. And so this is the title of one of our research paper on this. So exaggerated health news, the association between exaggeration in university press releases and exaggeration in news media. And what we did, this was a replication of a British study. We looked at all press releases sent out by university hospitals and universities about health news, about peer-reviewed research articles, Then we went back to all the original peer-reviewed articles, and then we went to the big newspapers and online websites to see what they wrote about it. And one of the things we looked about was where correlations presented as causal relations. So a study that says there's a link between two things, and headlines that say, eating nuts will make you live longer. And then what we found is that in the Netherlands, 20% of the press releases or news articles that a university sends out are already doing this. So that's 1 in 5. And then we saw in the media that 29% of the media did it. And there was a very big relation between the two. So if the press release was exaggerated, most of the media attention would also be exaggerated. And the other way around. And British researchers have done a randomized controlled trial where they send out manipulated press releases into the real world, where they only manipulated them to make them better, so they never made them worse intentionally. And they did see that this is really a causal relationship. So just by doing this better from within academia, you can improve how things are in the media. And just today I read an article about, I don't know if you've seen it, that there was this link found between getting a flu shot and having 40% less probability of Alzheimer's. And I also saw the news articles already that saying that a flu shot prevents you from getting Alzheimer. And I was already checking how their own university communicated about it. And I was saying, well, we cannot always blame the journalists. And then about averages, things are going well on average. And this is, I think, one of the things you see so often, and it's so obvious when you think about it, but you need to be reminded of it again and again. Is it very annoying for you if I walk around? I just saw the cameraman like, oh, okay. So, but this is an image of a lake where a statistician drowned because on average he could stand in the lake, but he couldn't. And this is what happens a lot. When you see an average, there are a lot of things you can think about. And I know for certain that this was in the reading material of the seminar here because it's such a classic example. This is an image by Darrell Huff. I will recommend his book highly to you. And Darrell Huff wrote a book about lying with statistics, and it was in the 50s. And everything you read in it is still being done every week. Like every example, every technique he describes, you see it happening everywhere all the time. And the fun thing is, he thought of writing his book when he read something like this, and I did the numbers to the average of today, so I used the inflation. So he read something that the average alumnus of his university made 250 and 111 a year. And Huff, who didn't make that much money, he wondered, like, how do they get such a precise average number? And also, who are these people? And this was in the 50s, and he realized that when you see an average like this, first of all, not everyone is in there. Like, who are the easiest to find? Is it the people who are very successful, or the ones who are lying in the gutter somewhere? And then, if you do find them to survey them about this, who are the ones who are most likely to answer? The people who are back to living with their moms because they're broke and divorced, or the ones who just started a business and are doing great? Probably the latter. So this is one of the things when you see an average presented, always check who's included in there and who isn't. But even if it's the entire population, still there is a lot to be said about averages. And this is also an image by Huff. So when he said it, these were yearly wages. Let's make it monthly wages for now. So this is a company. And at the top, you see a guy making $45,000 a month. Then you see some other managers at 15,000 or 10,000, middle management at around 5,000, and then at the bottom you see a lot of people doing the actual work for 2,000 a month. And then if the company says what the average person makes in this company, where would it be roughly? 6,000. Did you do the calculation? What? Oh, well, it's very good because it was 5,700. So very close, very good. And for most people, this is rather surprising. If you look at the group, there's only 1, 2, 3, 4, 5 people at or above the average, and the vast majority is below it. And that happens a lot. So, for instance, I don't know if you ever had this in Germany, but we had ministers of education saying like, "Oh, lots of schools are scoring below the average. That's a problem." And then people are like, "Yeah, always half of the people are below average." Well, it might actually be 90% being below average. And in this case, if the top guy decides, "I'm so awesome, I'm going to make $1 million a month," the average goes up dramatically, while none of them has anything more except the guy at the top. What I always like to compare it with, if Bill Gates would enter this room, on average, we would be pretty rich. But it doesn't help us. So there are two other measures that are used a lot to point out these averages, and probably someone already wants to shout them. Looking forward to it. So what are other measures that are often represented if you want to give something in one number to these numbers? Median, thank you very much. So the median is if you sort them all from low to high and then you put one in the middle. So exactly half of the people are above it and half of them are below it. And so here it would be at 3,000. So half of the company make more than 3,000 and half make less. And it seems so obvious, but even in science, I think we are generally reporting an average and not a median. And it's changing slowly. And of course, you would actually much rather have the entire distribution. But if you had to give just one number, the median would be, in general, much better. It's also much more robust. So if the top guy decides to go to 2 million a month, who cares? He's the guy. Then the median will stay at the same place. It will not change. And there's a third one, that's the mode. And that's the one that occurs most often. And in Dutch, we have Jan modaal and the modal income that is based on this word, but then actually defined with an average. So that's very funny, to me at least. So these examples are all coming from How to Lie with Statistics by Daryl Huff. You can buy it for, well, I think 7 or 8 euros. And it's really, really good and really useful. And there have also been new translations. And just to give one more example of how big this difference can be, this was a news article that says, well, American families on average have saved a bit less than 100,000 on their pension. And I gave a talk for people who worked on insurance for pension funds. And I asked them, what do you think when you see this number? And they all started discussing whether it was enough or not. So they said, oh yeah, 100,000, that isn't enough, and it should be more, and families, how much? And I said, the word average doesn't bother you at all? And then they looked at me like, why? I said, well, if you look at the median of all families that do have pension savings at all, it's 60,000. So half of all families have less than 60,000. If you take the median of all families, it's 5,000. So half, then all American families have less than 5,000 saved for their pension. I think that would be a more interesting discussion than whether the 100,000 is enough. If you have less than 5,000, it's clear that there's a huge problem. That's half of your society. So when you see an average, you always need to think about like who are the outliers, who are the ones that aren't doing so well. Then we get to topic number 4, and that's one of my other hobbies. So I'm collecting these examples of correlation and causality, but I'm also collecting graphs that are lying in some sense. And I have it's not German, it's from Österreich, but I thought I will do an example. So it's ein Überblick über die Anzahl der Menschen, die in Österreich in der Jahre 2007 bis 2019 die christliche Sakramente der Erstkommunikation und Firmung erhalten haben. So, and for those in the front, can you see what's happening here? Yeah, for those in the back, it might hurt, but the years are going the other way than you would expect. So it looks to be going up. So 2019 is here, and 2007 is over there. And this happens a lot. There are lots of things you can do with graphs. If your life looks miserable, there's always a way to make it look like it's going amazing. And one of the things that's problematic about these lectures is that you're always also teaching people how to do this. So I gave a lecture to a group of lawyers about lying with graphs. And then afterwards, one of them came to me and said, yeah, thanks for your lecture. I've used it. He had seen one before. He said, I've used it to win a case. And I said, you saw through the statistics of the other party? And I was like, no. I used everything you told me to make the most misleading chart I could. And then I wondered, what should we do? Should we then stop talking about this? But then I thought, no. If the other party had also come to one of my lectures, they would have seen through it. So I think what we need to do is talk about these things and these techniques. And when it comes to graphs, I actually think a lot of the ones that are misleading are due to stupidity and not due to badness. I will also have some examples of that. Let's go through some of my examples. This is one that started my collection in 2014. It's the book sales in millions in the Netherlands. So this is from 2008 up till 2014, and you saw a dramatic decline. And this graph was on national television when one of our book chains went bankrupt. And there were all these people on television talking about how these kids these days, they don't read books anymore, and everything used to be better, yada, yada, yada. And there were two things that immediately bugged me about this chart. So what would be the first thing? Technology, yeah, the technology also, but that was not specifically the chart, but yes. So.
Like the bars from 0 to 35 are missing.
Yeah, so they start the bar at 35 million and then they go up to 55. So if you would correct for that, you still see a decline, but it's much less dramatic like this. And then there was a second thing that bugs me, and that's a bit of a harder one, but I'm now looking at people who did Lying with Numbers seminar to see if they can take a guess. Yes? The population is shrinking. That's very good. Yeah, I once did a version where I corrected for how big the population was. Turned out to have a very small effect, but I did check for that. Now, it's something actually in how the graph was made that I thought was weird. This is maybe a very mathematical way. I thought it was weird. It was 2008 to 2014. I was like, why don't you do 5 years or 10? This seems so random. So then I looked at the longer term data. And since we're now in 2022, I also have the data from 2021. So this is all the way from 86 to 2021. And I stop at 86 because that's the earliest that we have the data from. And you see that there is a lot of waves going on. Then you see a really big rise here. That's because they used a new measurement method, and you cannot really tell what was happening before. And then you see there was indeed a dip at the time they were talking about, but then it went up again a bit. Last year went up. And I have actually the numbers here per person because I did the calculation. I have them on my sneak slide. So in 1988, we bought 1.8 books per person per year. And the record ever was 2006 with 3.1 books per person each. Yeah, and of course, there's a lot to tell about these graphs. So whenever you see a jump like that, you should check okay, that's weird. So there must be a way that they change the measurement. There must be some policy behind it. And of course, you can ask all these other questions. So I don't know if the person who mentioned technology also was thinking about e-books, because at some point e-books were introduced. Do you count them or not? And for bookstores, it's terrible. And also online bookstores are also terrible for bookstores, but they are selling books. And there are all these other interesting stories when you look at book selling data. So we're getting in lots of fields, we're getting different distributions. So where there used to be lots of titles selling quite a lot, now it's few titles selling really a lot, and the others selling almost nothing. So it's really bestsellerizing the book sales, which is also hard for physical bookshops because they have to have a few bestsellers, but then they want to have a broader spectrum, but then they need to have lots of books who all sell only a very little bit. So that was one of the things that started my collection. And it might be good to emphasize you shouldn't always start at 0. So this is like one of the things that people are like, oh, it doesn't start at 0, like the same when you now talk about a causal relation and people are like, correlation isn't causality. No, but sometimes we did an experiment that proves causality, and sometimes there are very good reasons to not start at 0. So when you're plotting someone's body temperature, would you go from 0 Celsius or 0 Kelvin? No, you would not. I think the general consensus is that when you do a bar chart, it shouldn't start at 0, but for line charts, there might be good reasons to not start at 0 and zoom in on a certain certain area of the data that is important. And it is very hard to get this specified. So 2 years ago, I had a master's student who looked at graphs that Dutch politicians were sharing on social media. And we had made categories of all the things that could be misleading about graphs. And then she found that half of the graphs she saw were misleading in some way, but didn't fit any of her categories. People can do so many things that are weird. But just to give some more classical examples, this was one from the British government that was showing how well employment was going. So the numbers are hard to read, but that's what they wanted, that you wouldn't check them too much. So before it was 28.8 million, but then after their plans, it was 29.9. And as you can see, that's 3 times as many jobs. But unfortunately for them, someone corrected it on the internet, and this is how you would see it in perspective. And you see that a lot now, that graphs are corrected and then they do it like this, so to put them up. There's a really, really nice analysis in the Washington Post about the graphs that Trump used in his first campaign. So here is a chart he showed that he was at 45% and Clinton was at 43%. And they did it the other way around. So they said, okay, if this is 43 and this is 45, where is the line where it's 0? Well, and it takes a while. I'll get some water. Still not there. Ah, there we are. So it's a rather small difference. And what is interesting is that the title of this article in the Washington Post, it's something like, most of Trump's charts skew the data and not always in his favor. And I think you see that a lot. So a lot of the charts that are wrong are done not because people are trying to skew the data, but just because they use Excel or PowerPoint to make the chart and they don't think about it. And the basic settings have been made by designers. And if a designer has to choose what's more interesting, a graph that goes from here to here or a graph that goes from here to here, they will go for the first option because it looks more dramatic, it's more interesting. So you always need to check the settings. But there are some graphs that I'm quite sure about that they were done on purpose. And this is one of those. So this is about gun deaths in Florida. And in 2005, Florida introduced the Stand Your Ground law that made you non-punishable if you shot someone on your own ground. And so here you see what this does to the number of murders committed using firearms. And can you see what's happening here? The y-axis is inverted, so up the top it's 0 deaths, and at the bottom it's 800 deaths. So if you would flip it around like a normal person would, you would see a huge increase of people dying. And the person who made this, she was asked about this, and she said, well, it was a very conscious decision to make it like this, because death is a negative thing. Then one I like a lot as a Dutch person. This shows how tall the Dutch are. And as you know, the Dutch are like really, really tall. Well, except for me. But, you know, whenever I meet someone from the Philippines, they're just up to here. It's how it is. Of course, this is also one where the axis has been misdone. Can be easily corrected. And then there's another sneaky thing in here. This is also 2D already. So if you make someone taller, he also becomes a bit broader. So we're taking in more area. You see that a lot in political graphs that they use, for instance, windmills or something else. And then you're already scaling in 2 directions if you make it bigger. So it's not like a bar chart where all the bars have the same width, but then some that are bigger are also broader. And in general, people read by intuition, they read areas and not length. So this is also a very sneaky trick, but not as bad as this one. That's the 3D pie charts, or as I like to call it, the work of the devil. This is an advertisement for Verna. You can see all the numbers in there, but I'm counting, well, except for you. You will probably do the calculations really fast. But what is the market share of the Verna? So here you see the pie chart. So is it 24%, 31, 38, or 45? So I'm going to do it by hand raising. So who think the yellow part is 24% of the chart? No one or some? Who thinks 31? Quite a few. Who thinks 38? Who thinks 45? Thank you. I think in a normal setting, you would say 45%, right? It's a bit less than half. It's quite obvious that it's almost half. But in this setting, of course, you're a bit more distressed. And I think the majority of you got it right. It is indeed 31%. So if you would show it from the top like this, it would become 31%. And then if you turn it a bit like this, there is a sort of limit in how much you can do in my program. So this is the worst you can make it at the front. And then you can also turn it all the way to the back if you hate the Verna. And what is nice about these tricks, if you see them, you can tell what people are trying to communicate. And so another Dutch university, not my own, used this pie chart in a presentation. So it's nationality of their students by percentage. And there we see Italian, Chinese, Russian, Indonesian, Indian, Brazilian, Tanzanian, American, South Korean, German, also quite a lot. And then there's this blue part in the back that's Dutch. So what are they showing? Oh, we're such an international university. Barely any Dutch people here. Well, if you would put the Dutch at the front, it would have been very, very big. So I always like looking at these charts and thinking what people want to show. Quite a while ago, I gave a talk about these things before a politician had to present their yearly results from their municipality. And he had made a presentation filled with 3D pie charts. And he had to present directly after me, and he couldn't change a thing. It was very nice for the citizens, not so much for him. So one research project I'm working on is how to correct these things. So how to correct misleading graphs. So this is one that's going... oh, this is actually a non-misleading one that's in there. Ha! I see, that's interesting. I don't know. Okay. This is actually a very non-misleading graph, I think. But imagine that the axes were like this. Now, so we are looking at bar charts that have exaggerated or non-exaggerated axes. And we're doing this together with someone who comes from a journalism background and is working on disinformation and fact-checking. And there's a lot of research in this area, and it's also very relevant. So, for instance, fact checkers used to use the thing that they checked to put it in the headline. So it would be the thing that was wrong, that would be the headline, like fact check, are nuts really killing people? And then they would say no. And then it's rather obvious, but you need to check these things. It turned out that people then remembered the incorrect statements much more. So now pretty much fact checkers worldwide are always using headlines that give the correct claim. So in case people remember just one thing, it's the correct claim. We were wondering about this for charts, like how does it work there? People read charts very differently. And so, so that's the journalism part, but there's also a statistician on board. It's very interesting. A lot of research in this area is done from very different fields. And there are also a lot of papers by statisticians who are telling what is the correct way to show the data. But they never check with an actual audience if it actually works. So during the pandemic, there were all these academics who were saying you should always show exponential growth on a log scale because then it's a nice straight line and it's much better to extrapolate. Then someone did an experiment where they showed non-statisticians and data scientists log plots, and then it turned out no one could figure out what they meant. So it might not be the best way. So we have a statistician on board who is thinking about how to communicate these things. And we have a postdoc who actually comes from film studies and who's very much into the visual rhetoric. So how people read this. So at first you always only look at differences. When you see a downwards trend, you're like, oh, something is going down. Then you think it's a trend. And then after a while, you might check the text and numbers, but it takes a while. And then we know that people who are low numerate, which is related to low literate, have much more trouble with this and get much more faults. So this is actually one that was misleading, and then the correction. So we checked different ways to correct these graphs. So one thing we did was just show the old graph and then give a correction. We also used more textual methods where we gave warnings or an arrow pointing at, look, this isn't zero, or just saying like, do you know that charts might be misleading? And then we checked like what works best, and also in different ways. So what works best to make people remember the correct version, but also what works best on the long term. Well, and in a research setting, a week later is already a long-term experiment because it's really hard to set it up later. But we did this with different ways, and then we checked 1 week later if we give people new misleading graphs, can they see through it? And actually the good news was that any form we used worked. So there were very small differences between the different forms, but actually all of them had very similar results, and it was very high directly after the experiment, and it lowered down a bit after a week, but the effect was still there. So that's nice, and we're now thinking of setting up an experiment to see whether the format matters. So these are like really boring graphs, and in some of the examples I showed, the corrections were like really in the same style as the original one. Does that matter? Should you take the effort to really make it as close to the original one, or can you use a more abstract version of it? So we're studying that. So here's a whole webpage about it for those of you who are really interested into this, and then we'll put what's happening there. But before all this research comes out, I'm still also sometimes using these charts myself. I make a photo comic for the Dutch New Scientist. I think there's also a German New Scientist, right? Oh, I see someone looking. There isn't?
There used to be one, but it's no longer on the market.
Ah, okay, yeah, because I did find some German covers on Google, but it quit.
Maybe 3 years or so.
Ah, okay.
In
Okay, so yeah, we do have a Dutch one, and they translate some of the British New Scientist content, and they make new Dutch content. And I do this with Ipadrise, who is a professional photo comic maker. It's a very weird occupation. We are friends, and we thought it would be fun to make a photo comic about science in a popular scientific magazine. And we've been doing that for a while, and then they had a new chief editor. And this is something in journalism, whenever there's a new editor, the first thing they try to do is get rid of all the columns and topics that are in there to start their own new things. So we were worried that we would be gotten rid of. So we thought, you know what, we'll show how successful we are in graphs. So this was the first one, the sales of New Scientist, since we were introduced into the magazine. Well, as you can see, we're doing like really, really well. We also did an analysis of the jokes we made. So here you see the jokes that were successful. Well, also the big majority went really, really, really well. And then, of course, we are also always really showing what readers think is important, because that's one of the main things in science communication. Always listen to your target audience. So is this your favorite feature in New Scientist? Well, you can also see that, yeah, it really, really worked out well. The fun thing is, this was published. The editor never said anything about it, and we're still in the magazine 4 years later. So, before we end, like, what are the things I would like you to remember from today? We did 4 things. So the first one was, be careful when you combine numbers. That was the Simpsons paradox, where you could have a trend in different groups that flips when you look at the entire group. And you need to think about that when you're working with groups. And sometimes it's the best thing to look at the subgroup. Sometimes you need to look at the whole group, but you need to think that this can happen. So always look at the relevant groups. Be very clear about the difference between correlation and causality. This is something where everyone can go wrong. It is very easy to think when you see something happening that there is a causal relationship. I recently also heard that cats do this. Did you know that? So if a cat eats something and then gets ill afterwards, even if it's because of a virus, they won't eat the same thing ever again, because they sort of couple it. And if you have enough food, that's a very smart strategy, right? You can eat something else. If you don't have that many foods, it might not be the best. But so be careful. And for the academics here, be very clear about this. Don't exaggerate your own results. Be fair, be precise. If you found a link or an association, that's also an interesting result. So when you see an average, always think about those who are not average. And this is not something in the numbers, but also I think idealistically. So if an entire group is doing well on average, it might be really good to check on, but are there some who aren't doing so well and can we help them? It is really good to always think about that and not be fooled by the average. And then the last one. Never trust anyone who uses a 3D chart. Thank you very much.